We are on the second page of your vocabulary chart. Our focus today is going to be with line segments. So our first definition today is that of a line segment. So notice it says it's a part of a line consisting of two endpoints and all points between them. So a segment is a portion. So if we were to draw a picture, we would start out, just going to draw a straight line. But because it's a segment, I'm not going to put arrows on it. I'm going to put a point at each end of that line. So that is a line segment, and I'm going to name those or identify those points as C and D. So now if I wanted to name that segment, I would put the end points, C and D. But to tell anybody, hey, that's a segment, it's not a line, it's not a ray, I would put a segment bar over the top of those 2 points. And notice that segment bar is just a bar, there are no arrows or anything. You can also change the order of the endpoints, and you could also call this segment DC. Again, don't forget to put the segment bar. Leaving the segment bar off has a different meaning, which we'll get to in a minute. So our next term is endpoint. So an endpoint, and again, the word tells you its meaning. It is a point at either end of a segment or the starting point of a ray. So I'm going to draw myself another segment. This one I'm going to label with endpoints P and Q. And then I will also draw a ray. So we haven't really defined array, but just very quickly, array is, again, a part of a line. It has one endpoint and continues infinitely in one direction. So I'm going to put my point A as the endpoint, and then I'm just going to put another point B on the ray. So if I wanted to describe those two figures using the word endpoint in my description, I could say points P and Q are endpoints of segment PQ. And then I could say that point A is the endpoint of ray A, B. We will talk more about rays and define them when we start talking about angles. But anyway, that's mainly to show you the meaning of the word endpoint. So there's another term in geometry that we use, or a phrase called betweenness of points. So if something is between, it's inside two other things. When we're talking about betweenness of points, I realize this is kind of a wordy definition. I'm going to read it, highlight certain parts of it, and then give you a visual to look at. So the definition for betweenness of points says, for any 2 points P and Q on a line, there is another point M that is between P and Q. So let's highlight that part. So another point M that is between P and Q. If and only if P, Q, and M are collinear and PM plus MQ equals PQ. Okay, so again, like I said, I'm going to break this down for you. So we're going to begin with a line. Oops. So I'm going to draw a line, and it is a line, so I'm going to put my arrows on the end of it. Now, I've got 2 points, so I'm going to put my point P here and my point Q here. So the first part that I highlighted is that M is between P and Q. It doesn't say where, and so I'm just going to put it right here. And now let's talk about that PM plus MQ equals PQ. All right, so what I've done here is I've essentially taken this line and I now have line segments on it. So I have portions of this line. So my first portion here from P to M. So that would be, I'm not naming it, I'm just going to say it has the length PM. So if I was measuring that would represent an actual length, a unit of measure. Then I have the other segment here, the other portion from M to Q. And so that has some unit of measure. And we're just going to designate that MQ. So when I take the two of them together, when I say PM plus MQ, that would give me my total length from P to Q. So that would give me PQ. So think back to when you first learned about addition. Addition is adding two parts to get a total. Well, for us in geometry, if we're looking at a segment, we could say that one part, or PM, plus the other part, MQ, would give me my total PQ. So that's what betweenness means. Main thing is that those points have to be on the same line. All right. Now, when we want to start talking about things that are the same size or same shape or have the same length in geometry, we have a word that designates that, and that word is congruent. So our definition for congruent is geometric figures that have exactly the same size and same shape. We do have a symbol for congruent in geometry, and it is the equal sign with a tilde over it. So anytime you see that symbol, that is congruent. So that's your symbol for congruent. So what does that mean for us in terms of segments? So if we want to talk about congruent segments, they are segments that have the same measure or the same length, okay, some unit of measure. So now let's talk about how we would sketch congruent segments to begin with. So in geometry, there's not a lot that you just can take for granted, or you can just look at a picture and say, oh, I know those parts are congruent. You have to somehow, the figures need to be marked. So I'm going to start out with segment AB, and then I'm going to draw another segment, and I'm going to label that segment CD. So, you could look at those two segments and say, well, they look like they're congruent, so I'm just going to say that they're congruent. You can't do that in geometry. Again, it's that precision. You have to be told. So we have marks that we put on segments to show that they are congruent. Some of you may be familiar with these, others not. So we use something we call tick marks. So if I put two tick marks on this segment and two tick marks on that segment, then that tells you that those two segments are congruent to one another. And I'm just going to circle those tick marks so they kind of stand out. So the thing to remember is that if you're looking for congruent segments, you want to look for tick marks. So tick marks show congruence. And the same number of tick marks on each segment tell you that those segments are congruent to each other. So you could have two segments with one tick mark each. I've got these two segments with two tick marks each. You could have two segments or more segments with three tick marks. So the number of tick marks tells you which segments are congruent to each other. Now, if I wanted to write a congruent statement, then what I would say is that segment AB, and then I'm going to use my congruent symbol, is congruent to segment CD. And when you're writing a congruence statement like this, the order of the endpoints does matter. So you want the order to be the same in both of the segments that you've named. Okay, so that's called a congruence statement. Okay. So now we're going to go to two more terms in geometry that you're going to hear a lot about, and that is sketch, draw, or construct. And so we're going to talk about the difference between those two. So when we're sketching and drawing, we are just simply creating a geometric figure either without using any tools or using measuring tools like a protractor or ruler. What we've been doing on this vocabulary chart is sketching and drawing. We haven't used anything like a ruler or a protractor. Well, sometimes we did use a ruler, but anyway, that's just sketching and drawing. And I'm not going to draw another picture, and there's no symbol. But also in geometry, what you hear about are constructions. And when you construct, so to construct a figure in geometry, it has a very precise definition and precise tools that you use. When you're constructing in geometry, you're creating a geometric figure accurately using only a compass and a straight edge. And hopefully at some point when we're back together, we will actually talk about and practice sketches with compasses and a straight edge. All right, so our last term for today is distance between points. So how far it is from one point to another. So when we talk about distance, so that means the length of, let me erase that. Sorry, go to my highlighter. So it's the length of the segment with given endpoints, or as I just said, you can think about it how far it is from one point to another. Okay, you've been finding the distance between points since you were back in kindergarten. Anytime you used a number line for counting, that was finding distance between points. So like I said, this isn't really a new concept to you. We just refine it a little bit for geometry. So I'm going to put a segment here. And I'm going to label my endpoints A and B. Okay, and then I'm going to divide that segment up into parts. Okay, so if I wanted to know the length of that whole segment, I always tell kids, count the bumps. So 1, 2, 3, 4, 5. So the length of that segment, the total length is 5 units. Okay. So we have to be able to symbolically represent the length of a segment. And the way we do that is I would say, okay, AB is equal to 5. So notice I have not put a segment bar above that. So there's a difference when you see a segment bar and you don't see a segment bar. So, back up here when we were naming our segment, there we put segment bars. But when you are just talking about length of a segment, there is no segment bar. So if you just remember that no segment bar for length, if you're actually talking about how far it is from one point to another. Okay. So that's all of our vocabulary for today. And again, as you can see, it all really relates to segments. So your assignment will be the practice that is for vocabulary day 2.